Hello everyone, my name is Athar Chauhan, and in this part of presentation, I'll be explaining how we normalize faculty workload values using three different techniques. Normalization is very important because it helps us compare values that exist on completely different scales. In many departments, faculty workload varies a lot. Some faculty members work around 200 hours per semester, while others may go up to 1000 hours. This huge difference makes comparison difficult. To solve this, we apply normalization techniques to bring all the values to a similar scale. Now, the workload data set we are working with contains values from 200, 300, 400, sorry, 200, 300, 400, 600, and 1000 hours per semester. These numbers represent different teaching and research responsibilities. Now, let's see how we can normalize them using three common methods. Now, why normalization matters? Normalization helps us in three major ways. Compatibility, when values are on different scales, comparing them becomes unfair. Normalization solves that. Second, better algorithm performance. Distance based algorithms and neural networks works much better with normalized data. Third, faster convergence. Algorithms like gradient descent learn faster when features are on similar scales. So overall normalization improves both accuracy and performance. Now, method number one, min-max normalization. Min-max normalization brings all values into range 0 to 1. It does this by using the smallest and the largest value of the dataset. In our case, minimum value is 200 and maximum is 1000. The range is 800. This method preserves the pattern of the data. The value with the lowest workload becomes 0 and the highest becomes 1. Now let's calculate it step by step. For 200, the 200 minus 200 whole upon 800 will give us 0. For 300, 300 minus 200 upon 800 will give us 0.125. For 400, it'll give us 0.250. For 600, it'll give us 0.500. And for 1000, it'll give us 1. As you can see, all the values now fall neatly between 0 and 1. Now, Z-score normalization. Z-score normalization transforms values based on mean and standard deviation. It tells us how far a value is from the mean in terms of standard deviations. For us, we have here mean as 500 and standard deviation as 282.84. This method is extremely useful when the goal is to compare how far each value is from the average workload. Using the Z score, we get 200 hours minus 1.06, which is below average. For 300 hours, we get minus 0.71. For 400, we'll get minus 0.35. For 600, we'll get positive 0.35, which is above average. And for 1000 hour, it is plus 1.77, much higher. Negative Z scores indicates values below the mean. Positive Z scores shows values above the mean. Third method, decimal scaling results. After dividing by 1000, we get 200 as 0.2, 300 as 0.3, 400 as 0.4, 600 as 0.6, and 1000 as 1. This method is easy to perform and great for quick pre-processing. Let's compare all three methods. All three techniques achieve the same purpose. They bring data to a comparable scale, but each one of functions differently. Minmax gives a fixed range of 0 to 1. Z-score standardizes based on mean and spread. Decimal scaling focuses on shifting the decimals. The best method depends on the data set and the algorithm you plan to use. Talking about the key takeaways, to summarize, normalization is essential when values exist on very different scales. Min max is best for bounded ranges. Z-score is great for statistical comparisons, and decimal scaling is simple and quick. Choosing the right method depends on outliers, data distribution, and your algorithm's requirement. I hope you like my video. Thanks for watching.